All right, just getting my little sketch together to show what the bar is going to look like and jot my dimensions down on how everything's going to fit through the clapper and the dimensions that I want that. So what I'm shooting for is approximately 12 inches of bar stick out. So I could have a 12-inch long workpiece that I want to go through. We're going to have a little bit extra on the end. I added a 1 inch on the end. We'll probably broach this for a 1/2 inch to be able to use 1/2 inch square tool bits on that end. So I've got it roughly 16 inches is going to be the total length of the bar. It actually equaled out to be 15 7/8, so I'm just going to consider it 16 inches. Like I said, that'll give me an inch on the end for the square hole, and that's it. So I'm not gonna cut it. I'm gonna chuck the piece into the lathe just like it is. You know, we're not worried about this OD at all. So it's all gonna be turned down. So I'll have a nice area to chuck on. We'll get it centered and we'll start doing all of our turning. All right, we got her chucked up. I haven't indicated it yet. We just got in there, tightened the jaws up. And we are gonna be running a steady rest. So what I'm gonna do, this is gonna be chucked real nice and true. I'll indicate it here, then we're gonna move down to this end and bump it around. And we'll get it indicated in 2 places, get it running really true. Then we'll set the steady rest to this end out here and to do our facing and drilling. About 50 thousandths off. I want to start with the high, make sure that it's tight. And then we'll move back around here to our low and loosen it. Tighten the high. Move to this one because it's low, and then snug it up. It should put pretty close. That's 1/1000 right there. All right, within 1/1000. So now we're going to move this down here and bump it around. Yeah, make sure y'all can see that. See, not too bad. That's 10 thousandths. So we'll take our knocker, just give it some taps on the high side. That's 3 thousandths right there. Still about 2. There we go. So that's about 1/1000 1/2, but that'll be all right. We'll go ahead and true up our steady rest to that, but I want to come down here and double check it, make sure it's not out very far, and we may have to do it again. So that's 1/1000 right there. All right, so we're running true. We can even turn this thing on, and I'll show you. There we go. Okay. All right, so this is how I set steady rest a lot of times. Bring in there a little bit closer there. I'm going to slow it down. Doesn't need to run that fast. I want to come up till I just feel pressure on the screw here. Usually you can see a little line on the surface. I can feel it rubbing right about there, so we're going to leave that one alone. All right. Same thing with this one. All right, I can just feel it touching it, so I know I'm there. Snug that out. We'll tighten those up again. Now I got my whey oil. We'll keep it lubed with some of the whey oil there. Now let's go ahead and tighten the bottom two. Just snug them, don't have to be full tight. And there we go. All right, notice that I checked the center of my tool and it's on center. We touched off. I'm going to take 50 thousandths. You know, that's really cutting like it's stainless steel. I'm going to reluctantly continue on with this. We're going to get it center drilled and start turning, but I really think that this is one of those grades of stainless steel. It just doesn't have the coloring in it like it should with the 1045. So I'm gonna make a cut across it in a bit and see, but we may be starting over, because I was planning on using some 1045 for a bar. I don't know if this is stainless, how well it'll work for that, but let's go ahead and carry on and see what we can discover, shall we? Let's see what kind of chip we can make. Looks like stainless steel to me. It's got the squeal also. Yeah. Well, I think I'm going to stop this right here, because I don't want to use stainless for the boring bar. I'm gonna dig around at work and see if we got any like 3-inch chrome rod scrapped that maybe I can use. This was, I thought, is what it was. I've had it under the bench for a long time. Didn't realize it was stainless. And through the miracle of time, we have a new workpiece in the lathe. So this is what I was looking for. This is the 1045 steel, chrome plated, and I've already went through the trouble of facing the end, center drilling it, so we can just start off where we had left. Got me a stop down here. This is about where we're going to stop. So this is our workpiece right in here. This is going to be left over for another job, and this will also allow me to easily clamp it in the vise and just cut this end off. Let's go ahead and get started on this thing. Let's see how this one cuts. That's a 200 thousandths pass there. So if I get any chatter, I can use my steady rest there up a little bit closer and get that vibration out, which is what it's acting like it wants to, but we're handling it. Probably going to go ahead and use my flood coolant. Get the pump going. Coolant's looking a little rank. That's what happens when you don't use it for a while and it sits, but it's still doing its job. I went ahead and tightened up the steady rest there. It did help take a little bit of that vibration out of the workpiece. In fact, I need to put a little bit of whey oil right there. Steady rest isn't tight. You just come up till it just touches just enough to keep the vibration off of it. Second pass, I stepped up the feed rate, changed out that insert too. We're running a Mitsubishi insert there. I've got a lot of different kind of inserts around here that people have given to me, and I like to try to just play around with them whenever I get a chance doing turning like this. That one seems to be working a little bit better. That's a 433, so it's got a much larger nose radius on it. And I can tell that I need some new coolant, so that's another one on the list. Go ahead and get a bucket of some soluble oil coming. A little bit more aggressive on this cut here. We're taking 300 thousandths now, running 420 RPM here. Getting down to our two final cuts on this area right in here. So I decided to go ahead and turn it to 2 1/8 since our threads is going to be 2 1/4. That'll give this an 1/8 of an inch clearance through the bore of the clapper there. Just splitting it into two cuts. I'm not trying to land on any specific diameter other than 2 1/8. So after this cut, I'll mic it and take one more pass down there. Still running a 15 thou feed rate, 420 RPM, and it's leaving a nice looking finish there on the workpiece. All right, just getting these two journals finished in here. Got two journals to make with an undercut, and then we'll cut a little radius there in that shoulder you see. This is going to be a thread relief. Using a high-speed blade there with the radius ground in it. I think we'll use that same tool. We'll come over here to this corner and just dress that up, make it look good. About that. All right, we got everything set. Got the cross slide lock set on 0. We touched off. We'll make a scratch pass. We're cutting a 12 pitch, by the way. Go ahead and give it a check with the pitch gauge. Looks like we're on it. Be going around 120 depth on the compound here. I'm going to go ahead and check it. I'm going to use my thread triangles to mic the pitch there. I've already got it calculated as to what the pitch should be when using these. I got a chart that comes with them that tells you whatever your pitch diameter or your pitch that you're cutting is. There we go. Alright, 2.524 is what we want. I'm at 544. 20,000. A couple more thousandths and we'll be there. I'm just going to keep skinning it away. Spring pass. $524. Alright, we hit our target. We just need to file it and polish it now. This is what I'm talking about. This is the thread triangles that I use and the chart that comes with it. And down here it tells you to, column A is your thread pitch, so I'm cutting a 12, and column B is what you add, is the constant that you add to whatever your nominal size is. So in my case, 2 1/4, which is 2.250, and then you add 0.2737 to that, and that's going to give you what you mic over with the thread triangles right here. And then this is just some rubber tubing. Actually, this is the tubing that I bought for the G&E shaper whenever I was fixing one of the oil lines there. Little piece there, 1/8 inside diameter. It was the perfect size for these thread triangles. So if any of you guys have these triangles floating around in your old toolboxes, get you some of this little rubber oil tubing, and it fits on these things perfect right there. The ends are turned 1/8 and they push in there and they stay. Alright, we have that guy finished up. Gave the threads a nice polish. Scotch-Brighted the whole thing there to brighten it up some. Looks good. So from here we're going to go out of the lathe over to the saw, cut this thing off, and then it'll be ready to go, besides the square hole that we're going to broach in this side. So what I'm going to do now is actually clean the lathe up. Since I've used flood coolant, the water getting up under there, I'm going to go ahead and clean it real good. Just using my WD-40, spray over everything and give it a wipe down to help dissipate all that water down there. So we're going to shut it down tonight, and then I'll come back out here in the morning and we're going to get this thing finished. Alright, we're ready to cut this bar off the stock. I still got to face it off. I want to clean that side up there, but I want to go ahead and give it a test fit. There's our clapper. Like it was machined for it. Yep. Everything's lining up just the way I wanted it to there. We're already good on the back, but I still want to clean it up. Can't leave that saw cut on there. Okay. Let's use our new 6-jaw to hold it. I forgot. We made that 2 1/8, and the spindle hole is only 2 inch. So let me pull it out just a touch. We should be able to face it off right there. Yeah, man. Just cleaning it up. All right, there she is.